The last conic section we're going to take a look at is the hyperbola in section 16.5. Somewhat similar to the way that an ellipse is constructed, a hyperbola is the set of all points. We'll call them P. This time, though, we're looking at the difference of the distances between two foci, and that difference is constant. So we get a hyperbola that has two branches, almost as if you took an ellipse, split it in half, and then spread it apart. The line that goes through the foci that intercepts the hyperbola, that happens at the two vertices. And if you could imagine an axis running through the foci and the vertices, that would be your transverse axis. So we mentioned that a hyperbola has two branches. It also has two asymptotes. So these are those imaginary lines that our graph will never touch. And you notice that the asymptotes make an X. They're the diagonals of a rectangle that has its center point at the center of the hyperbola. Similar to when we took a look at the ellipse, certain points of interest are named for you in your notes. The vertices, as well as the focus, and the transverse axis. So once again, we're going to consider, for now, only hyperbolas which have their center at the origin. If that's the case, the standard equation of a hyperbola with its center at the origin with a horizontal transverse axis looks like this: x squared over a squared minus y squared over b squared equals 1. So similar to our ellipse, standard form equation is always equal to 1. The difference here is instead of a sum, we have a difference. The equation of those asymptotes, and you could see that they're lines. So they're going to have an equation that looks like a linear equation. Y equals positive b over a times x, and y equals negative b over a times x. The vertices will lie on that transverse axis, and they're going to be at plus or minus a comma 0. If we have a vertical transverse axis, such as in this example, now our x's and y's change place. So y squared over a squared minus x squared over b squared equals 1. Transverse axis now vertical. Asymptotes are going to be, again, a line. But this time we go a over b for the slope number, plus or minus a over b times x, and for the vertices 0 comma a and 0 comma opposite of a. The foci will be on the transverse axis, c units away from the center, and we use a similar type of equation that we used when finding the foci of the ellipse. This time, though, it's a sum. C squared equals a squared plus b squared. So let's see what we can do with an ellipse, rather a hyperbola. Well, for one, we can graph them. So we're given this equation, 25y squared minus 4x squared equals 100, and asked to identify the vertices, the foci, and the asymptotes of this hyperbola. Well, our first step, we're going to put this in standard form. I've got 25y squared minus 4x squared equals 100. The right side of the equal sign, I want this to be equal to 1. So I'm going to divide through by 100. 25 and 100 have a common factor of 25. If I divide that out, 25y squared over 4. 4 and 100 have a common factor of 25. X squared over 25 equals 1. So now I've got my hyperbola in standard form. I have y minus x. So taking a look at my table from the bottom of the previous page, when I have y over a squared minus x squared over b squared equals 1, that's a vertical transverse axis. So my hyperbola will be up here and down here. So let's see how this plays out. So the vertices in a vertical transverse axis happen at 0 and plus or minus the a value. So here's my y squared over a squared minus x squared over b squared equals 1. So I can see that my a value is the square root of 4. It's 2. So 0, 2, and 0, negative 2. Let's place those points. Next, we want to find the foci. C squared equals a squared plus b squared. So my a value, a squared, is 4. My b value, b squared, is 25. So c squared equals 29, and c equals the square root of 29. So that's a little over 5, a little under 5.5. The foci, remember, lie on the transverse axis, so they're going to be a little farther away from the origin than the vertex is. And the last thing I need is my asymptotes. So looking again at our chart at the bottom of the first page, with a vertical transverse axis, my asymptotes happen at y equals plus or minus a over b times x. So my a value is 2. The b value, square root of 25, that's 5. So I have the point aligned with the equation 2/5 x. So starting from the origin, up to 5 to the right. 1, 2, 3, 4, 5. And conversely, down to 1, 2, 3, 4, 5. Missed my point there a little bit. And negative 2/5 x. So down to 5 to the right. And this point here. Remember, this is the rectangle that's centered at the center of the hyperbola. If you could imagine this rectangle, here's your other asymptote. And then, finally, the graph. The vertex here and here, and the curve of the branches of my hyperbola will approach but not touch those asymptotes. So something like that. So the graph of the hyperbola will look like this. Also, we can work backwards to write an equation of hyperbola if we know something, say for instance the foci and the vertices. So let's take a look at this issue. So vertices at -2, 0, and +2, 0. So this has a horizontal transverse axis. Foci at 3, 0, and -3, 0. So if it has a horizontal transverse axis, my standard form is x squared over a squared minus y squared over b squared equals 1. Now my vertices happen at plus or minus a comma 0. And I can see that my vertices are at plus and minus 2 comma 0. So I have one at -2, 0, and 2, 0. Therefore, my a value has to be 2. So I now have x squared over 4 minus y squared over b squared equals 1. And what am I missing here? Okay. I need a b value. Where am I going to find that? Well, I've got foci at -3, 0, and 3, 0. So remember, my foci equation is c squared equals a squared plus b squared. Well, I know my c value. That's right there. 3 squared equals a squared, that's 2 squared, plus b squared. So now let's simplify. 9 equals 4 plus b. Solve for b. So my b value equals 5. B squared then will be 25. So x squared over 4 minus y squared over 25 equals 1.